Ontario Ministry of Natural Resources and Forestry. I also need to start, I think, by talking a little bit, not too long, I could talk probably for hours, but a little bit about the biology of the American eel. It'll give you an understanding why some of the management challenges that we're faced with. American eel is the only catadromous species in the Great Lakes, so it has a very unique life history. It needs access to the ocean to spawn, so it spawns in the Sargasso Sea, south of Bermuda. And then its growth phase of its life cycle is found in freshwater areas like the Great Lakes and nearshore coastal areas in the ocean. It has this incredibly huge range, so you can see it runs from northern South America all the way up through Greenland, and is pretty much found in every watershed that accesses the Atlantic Ocean throughout this area. It's a panmictic population, which means it only has a single spawning population, so eels from across this incredibly broad range have to get back to a single location in the ocean to spawn. And it's also semiparous because of this huge migration. So for the eels that show up for us in the Great Lakes, it's about a 10,000 kilometer round trip. So these fish only spawn once and then they die. And so you can imagine from a management perspective, this species touches over 40 range states across its vast distribution. So trying to come up with a coordinated management strategy is very difficult, but also very important because a fish that's impacted in the Great Lakes is equally impacted to one that's down in Florida or somewhere else across this broad range. So this is an obligate migrant, and as such, it needs some special consideration. The species has declined tremendously, particularly in the Great Lakes, over the past 30 years. I'm going to show some data in a moment. And as consequence to that, it does have some conservation status across its range. So in the province of Ontario in 2007, when the Endangered Species Act came into force, it was listed as endangered. It has been assessed twice under Canadian federal legislation, our Species at Risk Act. We have a group called CSIWIC, which is the science community that assesses for conservation status, and twice it has been assessed. The first time in 2006 it was recommended for listing as special concern. The second time it got uplisted to threatened. However, the federal government has not yet accepted those recommendations, so it is not currently protected under SARA. And lastly, in the United States, it was petitioned for listing twice. First time in 2007, second time in 2015. Both times the U.S. Fish and Wildlife Service recognized that there were declines in eels, but didn't think that the species warranted protection under the Endangered Species Act at that time. As Aaron just showed, here's the nearshore goal for the FCOs for Lake Ontario, and American eel figures in there right at the end. And I'm going to spend a little more time dealing with the specific objectives for restoring American eel abundance. There are two objectives, one dealing with recruitment and the other dealing with escapement. The recruitment indicator is looking for a long-term target of the recruitment of at least 1 million American eels ascending up the ladders into Lake Ontario annually, and I'm going to show a little bit about what that means in a moment. And then there's a progress indicator for outmigrants. So eels have a number of life stages that we call yellow eels are the ones that live in the growth phase in the lake. When they're young, we call them glass eels. Those are the migrating stage for recruits. And then as they mature and outmigrate, we call them silver eels. So the progress indicator for these outmigrating silver eels is 100,000 silver phase, large female silver phase eels outmigrating annually. And we quickly saw this figure in Aaron's talk, or at least a similar figure, but I'm going to spend a little more time going over it. There are two main stem dams on the St. Lawrence River that block eel passage both upstream and downstream. The first dam is located the most furthest downstream in the city of Montreal, called the Beauharnois Generating Station. And then there's one at Cornwall, Ontario, and Messina, New York, called the Moses Saunders Generating Station. The most downstream generating station had an eel ladder installed in the late 90s, so its data series is a little shorter quite a bit shorter than the one at the Saunders Generating Station. There was an eel ladder put in place in the early 1970s. And then in 2006, there was a second ladder. Well, the first ladder was located on the Canadian side. In 2006, the second ladder was put at the station on the American side. And since then, the numbers from those two facilities have been or two ladders have been combined into this single index. So this is an index of eel passage, upstream passage, so recruitment into Lake Ontario in the upper St. Lawrence River. During the early part of this time series, there was a lot of variation in how the ladder was operated and designed. Lately, things have been much more consistent. So from about year 2000 onwards, individual eels have been counted as they've ascended the ladder. Prior to that, these are more estimates, and so we're not quite as comfortable with these numbers, but they simply are here to show the incredible difference in terms of scale of loss of the resource. During the early part of this time series, it was estimated between 500,000 and 1 million eels were ascending the ladder and recruiting into the lake. During the late 1980s, we saw this tremendous decline to the point where one of my saddest but favorite data points is here in 2001. There were less than 900 eels that ascended the ladder that year. So we had a tremendous 99.9% loss of this resource over a relatively short time frame. You can see since then we've had a little bump up in recruitment. So we had this nice increase through 2011, 2012, when we had over 50,000 animals come back. But since then, we've seen this drop again, although we had a little bump up this year to just under 24,000 recruits. We can also see this loss of a resource in the yellow eel trends. So this is, again, Aaron talked a little bit about the trawling survey in the Bay of Quinte. There's a number of stations done in the bay. They do 8 trawls at each station, and during the time frame when eels were abundant, you can see in the 70s we were catching quite a few eels in those trawls, even though they're probably not an ideal species for capturing in the trawls. You see this rapid decline with about a 10-year lag from the recruitment index to the point of year 2002, I think through 2011, not a single eel was captured in any of the trawls that were done in the Bay of Quinte. In the last few years, you'll note that there's been a couple of eels captured again, and those are most likely stocked eels, which I'll be talking about in a couple of minutes. The last FCO sort of graph that I'll show is one here on silver eel trends. We do not have a complete time series for this. So there is a silver eel fishery in the province of Quebec in the mouth of the St. Lawrence River. This is an important cultural fishery for them. And so even though eel numbers are plummeting, this fishery is being maintained, and we do view it as a relatively important source of data as a sentinel fishery. So we don't have, I don't have anyway, all of the long-term numbers, but I do have a few here to point out. So in 1990, there was 300 tons of silver eel harvested in the fishery. That number fell in year 2000 to 72 72 tons, and then the last 10 years or so, we have data. We started to work more closely with the province of Quebec starting in 2009. We've fluctuating trends in harvest between 10 and 20,000 tons of silver eel. So a pretty tremendous loss of a resource from 300,000 tons down to 10,000 tons this past year. Over the last 4 years, the province of Quebec went and measured the impact of that fishery in 2015. There was an estimate done in the early 90s that showed that the fishery took out about 20% of the eels that were out migrating, so there was a 20% harvest rate. That was redone as the fishery has shrunk since then, and so that was redone in 2015, and there was a 9.2% harvest rate. So by taking the amount of tonnage out of the fishery with that harvest rate and the average size of the eels, we can come up with an escapement number. And so we've started to do that. So in 2015, the first year we did that, there was just over 110,000 silver eels estimated to be escaping through the St. Lawrence River estuary. And that number has plummeted in the last few years as the last of those larger year classes of eels have gone through the system. So this past year in 2018, there was only 65,000 eels that were estimated to be leaving the system. And I'm pretty sure you can do the same math in the early part of this time series. We know then there was, with a 20% harvest and 300,000 tons of eels caught on an average size of, say, maybe a 1.5 kilograms an eel, there would have been about 2.5 million eels out migrating at that point. So to go from 2.5 million eels down to just over 60,000, again, just shows the tremendous scope of loss of these eels from the fishery and from the ecosystem. So as Aaron already mentioned, we're currently meeting our goals for the FCOs for eels, particularly on the recruitment side. The recruitment goal of 1 million eels annually has not been met for a very long time. The closest we actually got to that recently was in 1994 when there was about just over 100,000 eels that ascended the ladder. We're actually doing a bit better on the silver eel side. The long-term target of 100,000 eels was actually met in 2015, although the last 3 years we have fallen below that level. And I should note, this is for Steve maybe particularly, these are not stocked eels, these are all wild eels that I'm currently talking about. But I'm going to talk about stocked eels next for a couple minutes. At the end of my talk, I'm going to look at 3 things, but maybe only 2. I don't know if I'll have time to deal with the downstream passage in any sort of detail, but I will talk about the eel stocking experiment and the trap and transfer program. So the conservation stocking experiment, this was an effort to replace the lost eel recruitment that was occurring. There were approximately 4 million glass stage eels stocked into Lake Ontario and the Upper St. Lawrence River from 2006 through 2010. These eels were stocked to replace recruitment and the expectation that we would grow this kind of large female eel. I guess I didn't mention as part of the biology section that eels show dimorphism in terms of size and distribution. So Lake Ontario has only ever had historically female eels, and they've all been the largest across the species range, likely because it is at the extreme of the species range and they need to be that large to return back to the spawning area successfully. So we stocked these glass eels to replace recruitment, and we found about a whole bunch of really interesting things pretty early. Some of them were positive and some of them were quite negative. So I'm going to just briefly touch on some of these. Positive things that we found were that these eels dispersed widely, so we only stocked them in 2 main locations, but they were pretty quickly found throughout the lake, and including high up into some watersheds that eels hadn't been able to access for a long time. We don't know the actual survival rate, but we know it was incredibly high just given the densities of eels that we've started to see during the initial part of the study, and we continue to see to this day in some areas. The eels that were stocked underwent rapid growth, so they were growing on average of greater than 10 centimeters a year, which is much faster than the natural recruiting eels at the time. We weren't at all sure whether the eels would be able to outmigrate successfully, so the advent of this acoustic telemetry projects around the basin have allowed us to really look at that in detail. And not only did the eels manage to successfully outmigrate down the St. Lawrence River, we've been able to actually track them through the Gulf of the St. Lawrence, through the Cabot Strait, which is where Newfoundland and Cape Breton kind of get close together, and even down the outside part of Nova Scotia and the ocean through the ocean tracking networks arrays. So we know that these eels are able to successfully head back towards the spawning area. And the last positive point I have here is that we are starting to see increasing numbers of large female eels in the silver eel fishery that we can attribute to the stocking program. I guess I also forgot to mention that all of the eels that were stocked were marked with OTC, so we can identify those from the natural recruiting eels. Unfortunately, we did find a number of disappointing things when we stocked as well. So one of the first things we found were males. So as I mentioned, we had never seen male eels in Lake Ontario before, but for the first couple of years we looked, almost half of the eels that we sampled were males. And then we also started to see in reports from the Quebec silver eel fishery of these, they call them petite mature females, which they had never seen before in the 140 years that this fishery had been operating. And so this figure here, or this graph shows, this is a male silver eel. This is what we call our petite mature silver eels. They grow to, we're outmigrating at lengths of about 600 to 700 millimeters. And this is a more traditional large female eel, a natural recruit that typically outmigrates at around 900 millimeters to a meter in length. So we were seeing large numbers of these small females showing up in the Quebec fishery after only a few years after stocking. The next negative thing that we found was the presence of Anguillocoides crassus, which is a swim bladder parasite specifically targeting eels. This parasite has been contributed, or at least thought to contribute, to the declines of eels around the globe. And even though we had a pretty strong, what we thought was a pretty strong screening program prior to stocking, it seems quite likely that we introduced this parasite into the lake as part of our stocking program. And I have a slide to show a little bit of information on that, I think the next slide. And the last thing that we've been finding out is we have this pretty large difference in the timing of outmigration. So even as our stocked females get larger and begin to represent the size of these natural recruits, we're seeing that they're leaving Lake Ontario up to 2 months later on average than the natural recruiting eels, and we think that we're not really sure if those eels are actually going to be able to get back to the spawning area at the same time frame that the rest of the eels are. So I said I would just spend a moment talking about Anguillocolloides crassus. So this is the swim bladder nematode. We first found it in a couple eels in 2010, and it stayed at a very low prevalence for a long time. But then you can see in 2015 something happened, and the percentage of eels that we started to see it in increased. And it's kind of maintained its prevalence the last few years at around 30% of the eels that we handle have the parasite. In addition, the intensity of those infections has also changed, so the number of individual nematodes in a given swim bladder has gone from early in the time series, we were only ever seeing a single one nematode in a single infected individual. And then more lately, that number is starting to increase, and last year we had an average of over 6 nematodes per eel. So we're starting to see these rather large impacts there. You can see a swim bladder that's absolutely stuffed with the parasite, and we think that this greatly impacts their ability to migrate that 5,000 kilometers that they need to go back to the Sargasso to spawn successfully. Just wanted to spend a quick second showing how this size structure has changed and how these eels are now contributing to the fishery. So in 2011, you can see this almost complete size separation between the stocked eels and the naturally recruiting eels. By 2011, the yellow bars are now the stocked eels. We're still seeing some small stocked eels showing up in the Quebec fishery, but we're also seeing eels that are now over a meter long. And as a result, the number of large females that we can attribute to the stocking showing up in the Quebec fishery has jumped from the first time we saw a couple of thousand was in 2014, and then the last 3 years we've seen between 20 and 40,000 large females showing up in the fishery, which is quite good, because ultimately that was really our goal of this whole stocking program, our stocking experiment. And I think the last thing I'm going to talk about today briefly is the trap and transport program. This is one where because commercial fishers are encountering these eels as part of their entrapment gear, we decided early on in the eel restoration process that we would purchase those eels and then drive them around the 2 hydro stations. So if the eels are moving downstream naturally through the St. Lawrence River, they have to go through 2 sets of turbines. We know from empirical studies that 40% of the eels that do that end up being killed, and so this is a way to mitigate that mortality. Early on, we only had a fall fishery, only a spring fishery, and most of the fish were coming out of Lake St. Francis. But you can see over time, fishers in the Bay of Quinte in particular started to see large numbers of yellow eels showing up from our stocking program. So in 2015, we implemented a fall transfer as well. And you can see during the last couple of years, the impact, particularly in the upper St. Lawrence, of those stocked eels showing up. Last year, we had over 5,000 eels that were part of the trap and transport. So, and I think I had a bunch of slides that I'm not going to get to about downstream passage, but I'll skip to my minute of questions. So, thank you.